So in this video, we're going to review how you come up with your test statistic, and in this case, we're going to look at t-statistics. So in most applications, we don't know the population variance. So, by definition, this population variance, is the expectation of, y minus mu squared, where mu is the population mean, and y's are those random draws we have of our random variable. So oftentimes we don't know what the population variance is in the statistics. We don't know the true mean of the population either. So we calculate something called the sample variance. So this is like a natural estimator for the population variance. We usually denote that s squared, and that equals 1 over n minus 1. Then we sum up all the observations in our samples, subtracting the mean, and then squaring that. I equals 1 to n. So we're going to talk about a few different aspects of this sample variance formula. So the first thing you see is, instead of the mu that we see up at this top formula, we're using the sample average. That seems like a natural thing to use since we don't know the population mean. So we don't know mu, so use the sample mean, which, we're denoting by y bar. And the second thing you're going to notice that instead of dividing by 1 over n, if we had written out that population variance as in a discrete format, we have n minus 1 on this denominator on the sample variance formula. So here we're going to divide by n minus 1 rather than n. And this is because we're introducing like a slight downward bias by using this sample mean. So asymptotically, this makes it approach the actual population mean. So because we are using y bar instead of mu. So oftentimes you see this called like a degrees of freedom correction. In kind of, in layperson's terms, we're kind of using up some of the information in the data set by estimating this y bar. So if this above here is the sample variance, what we're going to call the sample, the standard error, I should say, standard error. So we're going to call that, SE of y bar, the standard error of y bar. SE of y bar equals S, so the square root of this s squared sample variance formula, divided by the square root of n. So this is our formula for the standard error of y bar. And we're going to need to use this when we estimate, so we calculate our test statistics and we perform our hypothesis testing. So as just saying, we often don't know the population variance. And so what we end up using is the sample variance, and we have this formula above here. And then we're going to define the standard error as this, the square root of this sample variance divided by the square root of n, where n's that sample size. This is going to allow us to come up with a test statistic called the t ratio or t statistic. So let's just put a line right here. So let's talk about the t statistic. Oops. Statistic. So we often call this called, the t ratio as well. So the formula for the t-statistic is y bar minus mu y0, and we'll talk about that in a second, over this standard error of y bar. So here, to kind of explain what everything means, y bar, oh, just kind of jump down the page there. So here, y bar is our sample mean. Mu y0, this is our, our hypothesized value. So it's some kind of number. So, you might be testing whether that mean equals 0, you might be testing whether it equals 6, minus 6, whatever. And like we just said, this SE y bar is the standard error of y bar. So when we know that y is distributed normally, if we know y is distributed normally, then this t-statistic is distributed as a student's t-distribution with n minus 1 degrees of freedom. Alternatively, if we don't know how y is distributed, we can use the central limits theorem. Can use central limit theorem. So the t-statistic, so t-stat or just t, I've been using t I guess so far, it's distributed asymptotically normally with a mean of 0 and a standard deviation of 1. So this t-stat, and knowing how this t-statistic is distributed allows us to come up with either, the critical values to know whether to reject or fail to reject or null, or alternatively, it's going to allow us to compute the p-value of the t-statistic, and we can use that to know whether we can reject or fail to reject the null. So in the next video, we'll go to the next step and we'll discuss, what critical values are and how we use them to get a conclusion about our test. And then we'll also talk about, what a p-value is, how we calculate a p-value, and how we use the p-value to get a conclusion over our test. And then hopefully we'll have another video where we can do an example where we kind of bring all these steps together.